Hey everybody, welcome to part 46 of the International IH350 utility tractor repair, or, well, it's not really a restoration, right? So it's just a repair. The saga, I should say, of the IH350 tractor. At this point, it's becoming a saga. I mean, I just said part 46, right? So anyways, today I'm going to do the final operation that needs to be done on that steering shaft, so that I can mount this new steering wheel, which is I'm going to cut a slot for a key seat, a woodruff key, and the first thing I wanted to talk about was the size woodruff key I ended up going with, and some observations which I found to be rather annoying. Mainly, I have a entire set here of woodruff key cutters. I'm sorry, woodruff keys. I have an entire set of woodruff keys over here with all of the many of the standard sizes, and the dimension, the thickness of this woodruff key. This particular one is 3/16 of an inch. The next standard size up, from what I gather, is 1/4 inch. Okay, which is this big sucker here. So it's a significant jump. The reason why I wanted to talk about this was I know how a woodruff key is supposed to fit in the slot, and it should fit snugly. Matter of fact, many a times it's taken some coaxing to get them out of the slot. That being said, my problem is, what I discovered is that this slot that was cut in this steering wheel, which was probably made overseas for cheapness, okay, this slot, I don't know if you could see that, but this slot is large for a 3/16 key. So that key is going to be sloppy, which is not good. But I think I'm going to have to roll with it, because the next size up, 1/4 inch, there's no way it's going to fit. Maybe it's a tapered slot, but it's not. 1/4 won't fit in that side, and if I put the 3/16 in on this side, it's just as sloppy. So that's not the answer. So my sneaking suspicion is that because this is made overseas, or my suspicion is A, this is made overseas, and B, that this slot is cut to a metric size. I have no idea why they would do that. All right, so right about now, some of you guys are probably yelling at the screen as you watch me, and you're yelling that, hey, what about 7/32? Well, I just went online here, and this isn't the machinery handbook, but it was just easier to Google it and find it. This is a chart, the ANSI standard chart for woodruff keys, and I noticed that when I was looking at the sizes here, there's 3/16, this is thickness now, 3/16, 1/8 inch, 5/32, 3/16, 1/4 inch. So that's what made me think that those were the only sizes available, because that's also what's in my set here. It goes 5/32, 1/8 inch, 3/16, 1/4 inch. However, turns out if you go up any larger than 3/4 inch, interestingly enough, there is an extra size in there. It goes 5/32, 3/16, 7/32, 1/4 inch. So 7/32 is between the two. It's a number 707 if it's 7/8, which is apparently the smallest. So let's see. So 7/8 width. So that would be a key this length, but it would be 7/32 thick. All right, so 7/32 is just a hair over 218 thousandths. It's about 218 and a half thousandths. So if I take, let's see, a 200 thousandths gauge block, will it fit in there? I'll tell you another thing too. This this cheapo steering wheel, they really did a hack job on cutting this slot. There's also looks like this was MIG welded. There's also a tiny ball of metal right there, indicating spatter left over from a welding process, probably MIG. That takes care of a little hunk of metal. It's actually still it's deformed. Well, I'll tell you, that slot almost doesn't even look like it's cut straight. That's going to be wonderful. As I sight down the bore, it looks like the slot might be going this way a little bit, and it definitely looks like the slot's tilted this way. That's unbelievable. Kidding me. What a piece of crap. So that's looking straight on at it with the camera. Can you see how that slot is tilted? The bottom of the slot is tilted to the right. So if I put the 200 thousandths gauge block in there, it does fit. And looking from this end, you can really see how the bottom of the slot, or the whole slot, is tilted. You can see the top of the gauge block as I hold it with my fingers tilting to the right. Well, the plot thickens. Remember I said 7/30 seconds is just over 218 thousandths. These are a 110 thousandth and a 107 thousandth gauge block put together. And so that's that's 217,000 that gives me. This won't fit in the slot. So the slot is not 7/30 seconds. There's no way a 7/30 seconds key is going to fit in there. That's a 100 thousandths and a 101 thousandth block, and that fits in there snugly. So the slot appears to be 201 thousandth. All right, so here's my plan. My plan is I'm going to use a 7/8 inch thick key, which is I think a 606. I already bought a new key seat cutter. Sorry, it's a 608. So it's a 608 key seat cutter, which is 3/16 inch thick by 7/8. Now, that's going to give me a slot that this is going to fit into nicely on the shaft, but it's going to be sloppy here. But what I think I can probably do is I might be able to, well, no, I really can't shim it because the shim won't fit in the slot that I'm cutting for the key. Damn it. You know what? Somebody already mentioned that I could probably rely on the taper fit alone to keep this from turning on the shaft, but I'm not 100% convinced of that. So what I'm going to do is I'm going to cut this, and I'm going to put this key in just as a little extra insurance, and the wheel is going to be able to turn a few degrees if it does start to shift on the taper. If it loosens on the taper, it will be able to move a couple of degrees each direction before it hits the key, which may over time cause the key to shear. I don't really like any of these solutions. Well, my favorite solution would be to actually, you know what? My favorite solution would be to cut a new slot, to ignore this slot that these guys put in here, and cut a new slot. And if this was a straight bore, I wouldn't be intimidated. The problem is that this is a taper. So I don't know whether or not, I mean, I guess for starters, let me see whether or not my broach set even has this size. Well, this is an old Minuteman keyway brooch set made by the Dumont Corporation of Greenfield, Massachusetts, home of Greenfield Tap and Die, so I wonder if there's some association between those companies. Anyways, it's, you know, was sitting around in a basement in an estate. I don't even remember how long ago I bought this, but the good news is it does have the 3/16 inch brooch in it, and it's got some of the feathers or wedges or whatever you call them, and it's got the collet, or the collared bushing as they call it. Okay, so this is too small, this one's too large by far. This one fits. Problem is, as I mentioned, fits from this direction and stops there because this is a tapered bore. So my concern is this gonna wanna move when I'm trying to cut the slot? But I'm thinking if I press this in straight, I should be able to cut the slot, hopefully. Well, after risking a hernia hoisting my large arbor press onto the bench top, I then realized that was a complete waste of time because there was no way I was going to be able to use the arbor press like I wanted to, because of the fact that the steering wheel actually hits the inside part of the arbor press before I can get this on far enough. So I thought about using the milling machine's quill as a press, but I don't really like the idea of doing that. I might be able to handle it for all I know, but rather than risk it, so I just decided I'm going to use my shop press. The lighting's not so great over here. So what I got for a setup is I get a couple of bearings. I save old bearings and I throw them in a box. I keep them here near the press to act as spacers because the height on bearings is precise. So, and by keeping different sizes, I can stack them and create different situations. The idea being is that I don't want to use this rubber or plastic that's molded onto the metal piece, the metal bushing inside there, as a reference. So by putting a small bearing in there that's about the diameter of this metal piece, I know that this opposite face of this metal is in contact and the rubber parts of the steering wheel are completely floating. Alright, I don't want to get crazy on this thing. I'll just end up damaging the tapered hole. So it's kind of a pain in the butt. I gotta, pump this handle until it gets to the end of the travel of the ram, then back off and put a longer spacer block in here and continue on like that. But eventually I'll be able to push that broach all the way through, and then I'll put the little shim spacer in there and do it again. Alright, so I made one full pass with the broach. Now I put this little spacer in that special bushing, and that'll move the broach over enough to make another cut. Alright, so I just made the second pass with the broach and the spacer in there, and the slot actually looks pretty good. That depth looks good right there, so I don't think I'm going to try and scare up another spacer and go any deeper. So now I just flip this over. Of course, because my hole's tapered and I'm cutting a straight broach, straight slot, it's much more prominent on this side than the other side. But I'll show that in a minute. So now I just got to push out the bushing. So looking from the large diameter side of the taper, you can see that there's barely a notch there. But on this side, it looks pretty good. So I want to get this set up so I can cut that slot. And I've got the shaft in my vise, but my vise right now, it's trammed and it's dialed into the head. So the jaws are perpendicular to this axis and parallel to this axis. And that's not going to do because I've got a taper here. So if I were to cut the slot with it the way it is now, what would happen is If this was a straight shaft, I'd be all set. But because it's tapered, it's going to cut more on this side than on that side, and I'm going to end up with a shaft that's deeper on one end than the slot that's deeper on one end than the other. So I set up an indicator here on the side, and I sweep back and forth across the taper right here. And what I'm going to do, I thought about it. I thought, well, you know, if I had a swivel base on here, I could easily dial in a few degrees at a time until I ended up getting the right setting. But I don't have a swivel base for my Kurt vise. Now I have an Elephant branded vise, which I believe was made in India. It's actually in excellent condition. It's a knockoff of the Kurt, and it's got the swivel base. So if I have to, I can take this Kurt off and throw that vise on here and use that. But I'm trying to avoid that. I think if I loosen the mounting nuts here for the Kurt vise, I think I might be able to tweak it just enough to get it to dial in. What I want to be able to do is when I sweep from left to right, I want to have the same indicator reading, and that would indicate that the face of this tapered section is then parallel to the x-axis, perpendicular to the y-axis. And then when I come in and cut my slot, it'll be the correct depth at both ends. Alright, so I took the Kurt vise off, and I was going to put on that Elephant vise, which is a big heavy monstrosity, and then I realized, well, you know, it doesn't have V-grooves in the jaws or anything, so it's not really well suited to holding round stock. I could put some V-blocks in there and do it that way, but then it occurred to me, why not just put a couple of V-blocks directly on the table and use hold down clamps? So that's what I ended up doing, and I've now dialed it in using my indicator so that I know that this face right here that I'm going to be cutting into is now parallel to the x-axis on the table. One thing I forgot to check was I kind of wanted minimum hangover from the block over here in the support. That way, because if I have it hanging over too far, then I'm going to have to put something behind it to stiffen it up, to keep the shaft from flexing from the pressure of the cut. But by doing it this way, I think not having much hangover over here, I think I can get away with not having to have any further support behind it. The only question is my spindle on the mill going to clear that? So I guess I better check that now before I bother going any further. That's better. I was wondering why the light was so horrible over here, even worse than usual. It's because my shop light that's to the right of us here off camera didn't start. So I guess I got a bad bulb or a bad ballast, electronic ballast in that thing. Well, it's running now, so it's probably the bulb. I don't know. Eventually, I'd love to convert everything over to LED, but all right, that's another story. So, where was I? I was going to check and see if the spindle's going to reach. Looks like that's going to be fine. All right, so the next thing I want to do is I want to set the depth of the cutter. What I mean to say is I want to set the place where I want the cutter to cut. So I want to cut right on the center line. All right, so halfway between the top and the bottom. All right, so all I'm going to do is I'm going to bring my cutter down to touch off on the full dimension of the shaft, which is right here. This is where taper starts here. So if I touch off here with the cutter, okay, and then I'm going to use the elevation on the knee to raise the table half the diameter of the shaft, okay, plus half the diameter of the thickness of the cutter. And that should put the center line of the cutter on the center line of the shaft. Start by cheating and bringing the spindle down because I don't want to crank the table all the way up. So I gotta bring this over so that I'm right there where the shaft is. So I think what I'll do is I'll come just off of that, lock the spindle. That should do it. So I just set my knee elevation dial to 0. Okay, that shaft is 7/8, so 875 thousandths total thickness at that spot. Divide that by 2, gives me 437.5. And then to that, I want to add half the thickness of that cutter. The cutter's 190 thousandths, so I want to add 95 thousandths. 532.5 thousandths. All right. So as far as where I want that slot along the length of the taper, I kind of want it centered, and it looks pretty good right there. I'm just eyeballing it. If anything, it might be a little bit closer to the threaded end than to the thicker end, which I'm fine with that. My slot on the steering wheel bushing actually, runs the full length of the bushing, so I'm not really too worried about that. So I got one other problem, or concern I should say, regarding getting ready to cut this woodruff key slot, and I figured I'd better illustrate it, so because I might not do a very good job of explaining myself. But here's my concern. This is a cross section of the bushing in the steering wheel, and there's the tapered hole. I've exaggerated it so that I can better illustrate the problem. So in order to cut to broach the slot in this tapered hole, what I ended up doing was I ended up using a bushing that came with the kit, as we already saw. Okay, that's a straight-sided bushing. And I pressed it in on the larger end, and then use that to guide the broach. So effectively what happened is the broach cut a slot in the side of the tapered hole that actually is parallel to the or perpendicular to this face, or parallel to the outside of that bushing, the outside wall of that bushing. In other words, the slot, because this is tapered and this hole gets smaller, the slot is very shallow at this end and gets deeper the further down the bore you go, until it gets to its deepest point at this end. All right, so the problem with that is, since the slot is not a uniform depth along the entire wall of the inside of that bore, how much of the woodruff key is going to stick into that slot, that's a number that's going to change depending on how far down the slot you go. So if we look over here on the shaft, so here's the shaft, here's the taper on the end of the shaft. If I were to not have aligned this the way I did in the mill, if I had just left it so that this side of the shaft here was parallel with the x-axis of the mill, and I come in with my cutter straight in this way, this is the effect I would get. The cutter would start cutting here first, and as the cutter moved in, I would end up with an effect of a deeper slot on this side and a shallower slot on this side. All right. What I've done is I've shifted this whole shaft like this, so that I've effectively brought this wall right here, this side, to be parallel with the x-axis. So now, instead of coming straight in with the cutter this way, I'm going to be coming straight in with the cutter this way. All right, and I'm going to effectively end up cutting a slot more like this. Okay, so the good news is that's going to be more like the way that it should be. and we're going to have part of the woodruff key is going to stick up out of that slot. And so by doing it, orienting it the way I did, effectively I'm going to have the same amount of woodruff key sticking up over here as I am over here. This is going to be a uniform, the distance from here to here is going to be the same as the distance from here to here, or very close to it. So that's the good news. The problem is, back over here, since I did not cut the slot at an angle the way that the taper is, alright, it's not going to match up. So to sum up, if this was a straight bore and a straight shaft, this would be a piece of cake. All I'd have to do is, you know that I want to have a certain amount of the woodruff key sticking into the bore and a certain amount of the woodruff key sitting in the key seat on the shaft. Alright, and we know what the dimension, I mean, it's easy enough, we can measure that. It's actually on the charts anyways, but we can actually measure the distance from here to here, and we know that we want a certain amount of this, and that's actually defined in the machinist handbook and on tables. It actually recommends the amount of this that you want sticking up above the shaft and into the pulley sheave, for instance, if it was that kind of a situation. We don't have that luxury, so I'm going to have a situation like this. So I'm not quite sure how I'm going to do this yet. If I use traditional dimensions in the book and I cut the slot to that depth, then there's the danger that as I go to put the bushing onto the shaft, we're going to run out of room. Now what might happen is, maybe, and this is what I'm hoping will happen, maybe the woodruff key will want to shift a little bit, kind of exaggerated here, shift a little bit so that now this is sticking up more where it can stick into the slot more, and this is sticking up less where there's a shallower slot. So I'm going to roll with that, and hopefully that'll work. So it looks like the depth of the slot needs to be 276 thousandths. It's got to be at least 276, and it can be up to 5 thousandths over tolerance. So why don't we make it 280 thousandths? The other thing I decided to do is, remember, I kind of eyeballed the location, and I was trying to aim for the center as far as left to right position of the slot. I think now, keeping in mind that the further I get towards this end, where the threads are, the deeper this slot is, I think I'm going to want to actually try and position the key seat closer to this end than the other end. Alright, so I'm just touching off right now, and I've set the Y-axis dial to 0. What I'm going to do is I'm going to put a stop over on the table, I'm sorry, on the ways, so that if I need to back the cutter way off to test the fit and I want to bring it back, I'll be able to find that spot again since I don't have a DRO. Yeah, it's not deep enough. Alright, so now that I know I want to go deeper, the trick is getting back to my starting point so I know when I'm exactly back in there. So I could actually just go in there until it touches off, but it rubs so much it's kind of hard to tell for sure. So that's why I set up this stop. So what I did was I put my Mighty Mag with this indicator, and I know that when I pull the table out on the Y-axis, I first touch off here and the indicator starts moving. If I bring this to 0 on the indicator, you actually can see that it actually is 0 on the dial. So you see when that 0 there lines up, my dial over here is also at 0, so I'm right where I want to be. Now, if I go in 200 thousandths, I should bottom out in that slot, and then I can just put on, I'm going to put on 80 more thousandths to get to the 280 thousandths complete depth. 80 thousandths. I fished this big hunk of steel, which appears to be, it's either milled really smooth or it was ground. I don't know what somebody was making. It looks like they were making a fence or something. And anyways, it's a really nice straight edge, and it's got a little bit of mass to it. And what I'm going to do is I'm going to take that, I'm going to put it right like that up against the sides of my two V blocks. And then what's going to happen is I'm going to unclamp this carefully, and I'm going to take that shaft out of there, and I'm going to try the fit, test fit. And if I need to make that slot deeper, the idea is that hopefully I can carefully put it back right into these V blocks, and I won't disturb my settings too much. Now I'll have to still find the going back and forth, I'll have to find exactly where the position is, and also I'm going to have to rotate this to the exact position. That's going to be a little trickier, but hey, it will be a lot better than having no idea at all as to where to go. I'm hoping that it's just going to fit on the first try, and then that'll negate all of this necessity. If I really wanted to be sure that I kept everything lined up, I could actually clamp this straight edge down to the table. It's not working. It only goes on so far and then it stops because it's hitting that. You see what's happening? This is swiveling out of the hole because it is too tight. Well, I wonder how much of that's sticking up. I just checked, and that chart says that this should stick up only about 93 thousandths, and right now it's sticking up about 108. That it almost seems to me that I could go 15 thousandths deeper and be okay. But I don't know. See if I can get this set up in the mill easy enough. If I can, I'll make this 10 thousandths deeper. Well, guys, I did it. There's the key. And that's just sliding it on there. I haven't even put a nut on it and started to tighten it. That'll pull down even further, and it'll just tighten up even more. So between the key being in there and the taper fit, I think that's going to be plenty strong enough. So I think I can finally call this shaft done. All right, so I didn't record it because I didn't want to bore you with a lot more video and make this any longer, but let me just show you how I ended up doing it. After I took the other 10 thousandths depth out of that hole and it still wasn't going to work, I decided that the way to go about this was to use the broach and try and fix that slot so that slot was more uniform depth all along the length of the bore. So what I ended up doing was I went back to the broach set, and I used this bushing, which is actually too small. It actually swims in that small end of the hole, all right, which is down there. But what I did was, since I already had a slot started, that took care of my alignment of the broach going in. So I was able to actually sit this in the hole. So the back side of this bushing was in the bore. Okay. Then the problem, of course, was that, well, this wasn't cutting at all, right? I needed to move this out. So first I tried putting in the little wedge here, and I was like, oh, that didn't do anything. But then I went and checked, and sure enough, I have a piece of 3/16" key stock. Well, it's actually a key. All right, so I put that in there as a spacer, and I put the brooch in, and sure enough, it almost worked perfectly. It went in at first pretty easily, and then it started to cut, and it actually ended up cutting in the bottom of the slot where it hadn't cut before. So now that's how I was able to get that to go on. So that's how I ended up doing it, in case you're wondering how I pulled it off. Wow, I can't believe it. This is amazing to me. This literally means that I think I'm almost out of excuses as to why I can't go back to that poison ivy infested field and start putting this steering box back together. Yeesh. All right, thanks for watching.